Well, hello guys, and welcome back to Mr. G Physics. Here's Mr. G, and this time we're going to be doing another question for the grade 11. This is going to be on vectors because vectors was done towards the beginning of the year, and maybe some learners already forgot how to approach this question. This is question 2 from November 2023, done in the Gauteng province. But before we move on, don't forget to subscribe for the channel so you can get the notifications and videos I post on regular basis. Other thing, I'm going to leave the question in the description below so you can answer the question before watching the video, and then you mark the question. The question said, consider the three forces acting on an object as shown in the diagram below, and then you have three forces. There's T, F, and W. Define the term resultant of a vector. So, to define a term's resultant vector is a single force, a single vector that will have the same effect as all other forces acting together. In this case, we're speaking about vectors. So let's erase this word forces and write vectors. It's a single vector that will have the same effect as all other vectors acting together. If they are for resultant force, then instead of vector, you write force. Guys, this definition is 2 marks. Every definition in physics is 2 marks, and it's quite simple. You have to memorize that one. Determine the magnitude and direction of the resultant horizontal and vertical forces. So now, for the horizontal forces, what we have? We have T and we have F. None of those forces are acting on the axis. So you need to project them to the axis in order for you to calculate the component. So T, for instance, we have a component on the x-axis which is pointing to the right, and this one is what we call T in X. You notice that T in X is the adjacent side to that 45 degree. So in this case, that is going to be equal to T, which in other words is the hypotenuse multiplied by the cosine of theta, which is 45 degrees. That is the horizontal component of that force called T. All right, now on F, we have the same. This force F is being projected to the x-axis and is going to have the right on the x, what we're going to call F in X, or also the horizontal component of that force F. Okay, and this one is also the adjacent side of the angle. Let me just move this one a little bit to the down. So F in X is equal to the hypotenuse, which is F, that is the hypotenuse multiplied by the cosine of 20 degrees. Guys, F in X not necessarily is always going to be cosine. You have to look at the angle and you have to identify which one is the vertical of the opposite side, which one is the horizontal, the adjacent side. So that is mathematics. Now we have one pointing to the right, one pointing to the left. Those are the only two forces acting there. Then right in here, we can say F net in X, or let's write FRX. FRX is equal to TX plus FX. All right, that is a vector addition. Now, the right way is to say that right or left is positive. It's entirely up to you. I'm going to write positive is to the right. Right is positive. It means that T in X is positive and F in X is negative. So that is important. Now we have TR or FR in X is equal to T in X, which is positive, is T cos of 45 degrees. I'm going to move all that a little bit to the left, minus, because it's pointing in the opposite direction, it's pointing to the left, minus F cos of 20 degrees. Okay, let me just move it a little bit more. There we go. Alternatively, you can do the calculation separated. If you want, you calculate T in X, which is just here. This will be 250 multiplied by the cosine of 45 degree, the answer is 176,777. Let's round off to 3 decimal places. This one is to the left. So this is going to be positive. And then f in x, if you substitute, we have 150 multiplied by the cosine of 20 degrees. And this is equal to 140,954 Newton. Now you may substitute those two answers in the equation. It does not really make a difference here. This is FR in X. All right, so this is going to be equal to 176,777 minus 140,954. All right, so the FR in X is going to be, let's write it here, FR in X is going to be equal to 35,832. And this is right. So this is the answer of the horizontal or the X resultant. That is our first answer there. I hope it's clear. If it's not clear, guys, you can write a comment and I will repeat. It's not a problem. I will do another video or re-explain. Now, in terms of the y-axis, we also have to calculate the resultant in y. Each of the forces will be also projected to the y-axis. So here, at this point, we are going to have, this one is t in y, which in actual fact is the same as this line here. This here is also t in y. T in y, which if you look carefully is the opposite side to the 45. This one is the opposite side to the 45. So t in y, and I'm going to write it right here, is going to be equal to t, which is the hypotenuse, multiplied by the sine of theta, which is 45 degrees. Remember, you do not memorize this one. You have to rather look at what side is the opposite and which one is the adjacent. And when we do here project this f to the y-axis, similar to the previous, we have here the f in y. This one is f in y. This is the same as if you write it there. This one I'm doing it for you to see that is the opposite side. This one is f in y and is opposite to the angle of 20 degrees. This is opposite side. Therefore, the force in y is equal to the product of the force, which is the hypotenuse, multiplied by the sine of the angle, which is the opposite, is 20 degree. This is 20 degrees. And guys, what other force do we have in the y-axis? We have W. Those are the three forces that we have in the y-axis. So now you have to select the direction. Either one is right. You can say up positive or down positive, is entirely up to you. But at the end, you have to come to say that FR in y is equal to T in y plus F in y plus W. I'm not projecting. This one is just the vector addition. So now you select the direction. Up is positive. And you know what? You may avoid this step if you want. If you want, you may avoid this first step. You can already say up as positive. And if you say that, then it's going to be FR in y is equal to T in y, which is positive because we select up as positive. Look at the picture. Plus F in y, which is also positive, minus W, which is negative. Guys, you may do the calculation now, separate it if you think it's going to be too much in a equation here. By saving the space now, I'm making too much stuff here. So let's calculate each of them on their own. So here we go. T in y is equal to T multiplied by sine of 45 degree. This is equal to 250 multiplied by sine of 45 degree, and this is equal to 176,777 Newton. I'm going to write up. All right. So let's calculate now F in y. That is equal to F multiplied by sine of 20 degree, and this is equal to 150 degree Newton, multiplied by the sine of 20 degree. This is going to be equal to 51,33 Newton up. I rounded off to 3 decimal places because this is not the final answer. The final answer must be rounded off to 2 decimal places, but the middle step you shouldn't round off, okay? So these are t in y and f in y. We can now come and write this part. You know what? I'm going to copy this one and move it down here so we can do it in this nav. We have enough space here. There's no need for us to press in there. So here is what we are going to do there. We're going to substitute all the values. And this is how you solve it. FR in Y is equal to 176,777 plus 51,303 minus W, which is 100 Newton. Look at W here in the graph or in the drawing. Okay, so here, what answer are we going to have? Well, I get 128,08 Newton. This is also up. How do I know it's up? Because it's positive, and I said up is positive. So this is my answer for the Y resultant force that was also asked. So here is the question 2.2. We're starting here on the right. It's a little bit pressed, but I hope if you were following me that you understand what I did in that part there. And here is the T in Y of the resultant force in the Y axis. Okay, the only thing missing here is the vector sign. Now question, okay, maybe I should give you the marks, or for you to know where the marks are allocated in this specific question. Okay, so there were only 4 marks here. 1 mark is for both components of T in X and T in Y. So there is 1 mark for calculating this one, as well as calculating T in Y. So the mark is for both of them, not for one of them, for both of them calculating. That is 1 mark. Let me take off this stick here. The other mark is for calculating T in X, which is calculated, F in X, which is calculated here, and F in Y, which is calculated below. Yeah, that is the second mark. You get 2 marks. 1 for calculating the components of T and the components of Y. 1 mark for calculating the F in Y, the resultant force in X, which we calculated up here. 1 for calculating that one, and the last mark for calculating the resultant force in Y. Those are the 4 marks. It's a little bit stingy from my point of view, but well, that is what we have. Okay, the next question, determine the magnitude and direction of the resultant force acting on the object. Now guys, this is not a difficult question, but I highly recommend you to do a rough drawing so you can have an idea where are we dealing with. This is question 2.3. So what we have that the resultant force in X was equal to, and we go here, 35,832 Newton to the right, and we have that FR in Y is equal to 128,08 Newton up. Now, what did I do this one? Well, we need to get an idea in terms of the direction. We have that FR in Y is up and equal to 128,08 Newton, and we have that FR in X, which is a smaller one, but this is not at scale, so it doesn't really matter, is going to be equal to 35,832 Newton. Well, the resultant, and guys, be careful. I often see that children attempt to do this one. That is wrong. You don't do that. That is completely wrong. So you have to draw a parallel line to each of them. You take your ruler and you draw a parallel line to each of them. The resultant is the force that is going from the tail of both of them to the head of both of them. This one is the resultant, FR, from both of those vectors. Now, the thing is, to calculate the magnitude is not a big deal. We have to use Pythagoras, okay? So how do you use Pythagoras? FR square is equal to FR in x square plus FR in y square. Alternatively, you can write straight FR is equal to square root. Remember, to cancel that square, you have to use the square root of FR in x square plus FR in y square. This is how we calculate the magnitude. This is to calculate the magnitude of the resultant force, okay? So the rest is substituting. And we get that the answer of the resultant force is 133 Newton. This one is just the magnitude. Now, to calculate the direction here, we have two options. Option 1, we calculate this angle here. Option 2, we calculate this angle here. It's entirely up to you which one you want to calculate. I am going to calculate this one. That will be from the positive x-axis. You can also say above the horizontal axis or above the horizontal. So that is the option I'm going to use. Now, for that option, you can see that the resultant force in x is the adjacent side, and you can see that the resultant force in y is the opposite side. So we can use tan of theta. Remember that tan of theta is equal to opposite side divided by adjacent side. All right, so if we do here, what do we get? That this tan of theta is equal to, opposite side is the y component, which is 128.08 08 divided by the x component, which was the x resultant, which was 35.832. All right, you calculate this one and you get this is equal to 3.574. I'm going to leave it there, but that is not theta, that is tan of theta. So to calculate theta, now that's equal to 10 of the minus 1, and you can type it exactly like this in the calculator, 3.574. You can do it already like this from the beginning, and when you do that one, you will get that the angle is equal to 74.37 degrees. That is the angle we just calculate. But now we cannot leave the angle just like that. The final answer, guys, will be 133 Newton at, so let's write the final answer. How it should be written there? We should say FR is equal to 133 Newton at, and then you write the angle at 74, for example, 37 degree above the horizontal. That is the correct answer using the direction. So that is the answer for this specific question. In this question, they gave 1 mark for substituting into the Pythagoras equation and 1 mark for calculating the magnitude of the force. They gave 1 mark for substituting into the tan of theta. You can use tan, you can use sine, according to what you want. You have all the values there. 1 mark for the final answer of the direction, and then they gave 1 mark for writing the final answer correctly with magnitude and direction. That is this question. I hope you understand. It's a good question. And the final question is the tricky one. So give the magnitude and bearing. Bearing is in direction, guys. We're going to explain about bearing real fast, of the force that can balance the system. Now, I really want you to write this one in your book. The force that can balance the system, remember the system is not balanced, so the force that can balance the system is what we call equilibrant. equilibrant. And the equilibrant is the force that will have the same magnitude as the resultant force. It will have the same magnitude as the resultant force, but it will be exactly in the opposite direction. It will be in the opposite direction. So I highly recommend you to write those two notes. Equilibrant is the force that have the same magnitude as the resultant force, but it acts exactly in the opposite direction. So they must be along the same line. Now, bearing is a way in which we can give direction. Now, how does bearing work? Bearing, and let me write it here, bearing. For bearing, you will always begin starting from north or from the y-axis. That is how we give bearing. Always you starting from north. This one is the 0 degree, and we use 3 digits. So we measure from north, and obviously we must know where north is allocated. So we measure from north, and we're going to count clockwise. So we're going to move in the clockwise direction here. Always we move in the clockwise direction. All right, so that is how we work with bearing. For instance, the resultant force that we got is this force here. This is Fi, which we got, which is equal to 133. Okay, let me move this, which is my place, move it there. This is equal to 133. Oh my goodness, that's still in the middle. 33 Newton. All right, so if we use bearing to represent the direction of that force, we have not other thing that give this specific angle. That angle will be the bearing. And if you do calculations from here, that angle will be the bearing. And in other words, that angle will be equal to 90. That angle there is going to be equal to 90 degree minus what we calculate here, which was 74,37. And that is equal to 15,63 degree. That is bearing, or the bearing that we're using for that specific force. So this angle here is to be, and we say at bearing of 0.13, 15, oh my goodness, 15,63 degree. It's a 3-digit number. But now, what is the equilibrium, which is the question actually here? So the equilibrium, remember, is the force that have the same magnitude, so it must be along the line. It must be along the line. Here, this force here is what we call the equilibrium. That is F equilibrium. I'm not going to write the whole word. Please, if you watch the video, write the name of the force. That is the equilibrium. That is the equilibrium. The magnitude will be the same one. It will be equal to 133 Newton. The direction they wanted in bearing. So using bearing from north, we have to determine all this angle because we're moving clockwise from north. All right, so we need to know this angle here. This angle here, I'm going to call it theta, and now you know more mathematics that I do. That angle there is this angle here. They are an opposite. You can see there. They are opposite to each other. So this angle here is 15,63. So what is the bearing? If we do calculation, this is 180 plus that specific 15,63. And that will be equal to 195,63 degree. That is the bearing. So the equilibrium is going to be the following answer. F is going to be equal to 133 at bearing 195,63 degrees. That is the question. Remember, all these drawings are not at scale, guys, and that is the end of the question. I really hope it helped. If it helped, all you have to do is to thumb up to show that it helped. And then don't forget to subscribe for the channel. I'll see you next time with another video. Thank you for watching once more. Mr. G here.